fine. Chaliye, we should start. I think Arslan has not joined yet though. No, we were doing aldehyde, ketones, and carboxylic acid. Just give me a second. And we completed till the aldehyde and ketone part. Today we will be doing the carboxylic acid part. Okay. So you write the topic first of all. That is method of preparation. Okay. MOP of carboxylic acid. Right, number 1. From primary aldehyde and ketones. Aldehyde नहीं, पहले alcohol लिख लीजिए, alcohol and aldehyde. Alcohol and aldehydes. Okay. So for this we will use oxidation. So we know that when you have 1 degree alcohol and you use any of this strong oxidizing agent, it turns into carboxylic acid. Carboxylic acid with the same number of carbon atoms. So if you have our CH2OH and strong oxidizing agents such as acidified CrO3. Okay. So if you are using only CrO3, then that is a weak oxidizing agent. But if you acidify it, then it becomes chromic acid, and chromic acid is what? It is a strong oxidizing agent. And this reagent, it is known as Jones reagent. Okay. And it gives you carboxylic acid, that is RCOOH. Now, important part here is number of carbon atoms remain same. Similarly, for example, you can write OH, it will give you 2 carbon atoms, CH3, COOH. Similarly, if you have something like this, primary alcohol, if you use, let us suppose, you can also use KMNO4, and you can also use K2Cr2O7. These are already present in your notes. एक नया आप याद कीजिएगा यहाँ से, Jones reagent. This is going to give you, there are 3 carbon atoms and 1 branch, and this will be COOH. ठीक है, generally बच्चे जो mistake करते हैं ना, they write it like this, and then यहाँ पे COOH, they write it like this, carboxylic acid. This is wrong. ठीक है. If you want to write it as it is, then I will tell you a trick. What you need to do is write the OH also as it is. ठीक है. OH as it is, बस यहाँ पे C double bond O कर दीजिए. This is carboxylic acid that you are going to get. ठीक है. But still, I would suggest that you count the number of carbon atoms. That is the best way to avoid any mistakes. Now we have already seen this. Then for aldehydes also, please see. Right, next point, aldehydes can be oxidized using milder oxidizing agent such as Ag positive and copper 2 positive. We have already learned this. Ag positive is used in Torrance test and copper 2 positive is used in Felling test. So both of these, Ag positive and copper 2 positive, they oxidize the aldehyde to carboxylic acid and they themselves get reduced. Ag positive get reduced to Ag, making silver mirror. Copper 2 plus gets reduced to copper positive, giving a red PPT. Okay. So these two, Ag positive and copper 2 positive, can also give you what? Can also oxidize the carboxylic acid. So if the milder oxidizing agents are able to oxidize the aldehyde to carboxylic acid, then obviously strong oxidizing agent will easily oxidize the aldehyde to carboxylic acid. Okay. So if you have RCHO, oxidizing agent, but please remember it should not be those controlled oxidation, PCC, PDC, and chromic anhydride. It should not be those because they stop at aldehyde, they don't react further. Okay? So it will be oxidizing agents such as KMNO4, K2CR2O7, Ag positive, Cu2 positive, HNO3, all of these things. They'll oxidize to RCOOH. Here also the number of carbon atoms are same. Now here if you are at 1, 2, 3, 4, CHO, and let us suppose you are having Ag positive, in the presence of water, it will be written like this. Then you will have the same number of carbon atoms and you will have carboxylic acid like this. Similarly, if you have something like this, CHO, and in the presence of, let's suppose you have Jones reagent, which is CrO3 in the presence of acid, you will have the same thing as it is, and the CHO will be converted to COOH. 3 carbon atoms, CHO, in the presence of KMNO4, you have 3 carbon atoms and you will get carboxylic acid. Okay, please copy this down. Raise your hand once you're done. If you want to look up, you can also see here. Okay. Moving on. Please write next from alkyl benzene. Okay, this will be very much used for the preparation of benzoic acid generally. Yeah, alkyl benzene, that means you should have benzene ring. And an alkyl group attached to it. What the reagent that you need here is a strong oxidizing agent, that is KMNO4, in a strong condition, that is with heat and a basic condition of KOH. So first of all, what will happen? Whatever the number of alkyl, whatever the number of carbon atoms is present in the alkyl group, that doesn't matter. You will have COO negative and K positive. That is because of the basic condition. Once you add here H positive in the presence of water, you just need to hydrolyze it and you will get the benzoic acid. So it doesn't matter if you have toluene. First step, we have MnO4 negative, heat, and KOH. Second, we have water in the presence of H positive. You will get carboxylic acid, and specifically speaking, you will get benzoic acid, COOH. Similarly, it doesn't matter if you have even 2 carbon atoms attached in the benzene ring, CH3, CH2. If you have the same reagent, you will again get what? You will again get the benzoic acid as it is. Now, if you have 2 alkyl groups attached to it, you have CH3 here, you have CH3 here, and you have the same reagent, then both of the CH3s will be converted to carboxylic acid. Okay. So when you have 2 carboxylic acid in the ortho position, this compound is known as phthalic acid. PHTHLIC. Phthalic acid. Raise your hand once you're done. If you have 2 CH3, by the way, then it is known as orthoxylene. Xylene is a compound in which benzene ring is having two methyl group. So when xylene is treated with MnO4 negative heat and KOH, then hydrolyzed with H plus and H2O, it gives phthalic acid. Raise your hand once you are done. Waiting for Yusuf now. Right. Next, third is from nitriles. Third is from nitriles and amides. A very similar reaction is there for nitriles and amides. So when you have nitrile, that is R, that is having carbon triply bonded with nitrogen, when you add water to it, then what happens? One of the carbonyl and nitrogen atom gets the two hydrogen atoms. Okay, so आपके पास क्या मिलेगा? R as it is. Carbon will get oxygen, double bond O, and the nitrogen will get NH2, making it what? Making it an amide. This is amide. Okay. And what is happening here when we are adding water, but this is partial hydrolysis. We call this partial hydrolysis. Okay. This is partial hydrolysis. What will happen with the complete hydrolysis? So in enough amount of water, what would happen? This amide will be getting converted to carboxylic acid. Okay. Now this would be in the presence of H plus or OH negative. Okay. And some kind of heat. Then you will get R, C double bond O, and you will have OH. It is much faster if you are having OH. Okay. If you are having the basic condition or acidic condition, it's much faster. So if you have nitrile, then the same number of carbon atoms. Please remember that. Right? If you have nitrile CN, you have first step में पानी, second step you have H plus, or with the presence of heat, you will get 3 carbon atoms and COH. Let us suppose you have amide, 3 carbon atoms, amide, CONH2. First step is only you need only one step, that is H plus in the presence of heat, you're going to get COOH. Make sense? Yes or no? Please tell me.
Yes, sir.
Okay. So this whenever you see CN now, then you should remember that this reaction can be used in order to do the ascending type of conversion. For example, if you have something like this, दो हम आपको conversion बता रहे हैं यहाँ पे, ध्यान से देखिएगा, है ना? Please don't write now. Try to understand. You have ethanol to ठीक है. So this is simple conversion in which you have two carbon, ethanol, 2 carbon atom OH, and ethanoic acid is 2 carbon atom COOH. So we have just seen that what we should use. We can use any of the strong oxidizing agent. Jones reagent अभी हम लोगों ने पढ़ा है CrO3 in the presence of H positive. ठीक है. That you will use. You will आसानी से क्या मिल जाएगा? You will get ethanoic acid. But if you have the same ethanol, another question. ठीक है. Please see. We have ethanol, but now you need to make ethanol to. They are saying propanoic acid. Propanoic acid. So here you have how many carbon atoms? 2 carbon atoms. Here you have 3 carbon atoms. So as soon as there is an increase in the number of carbon atoms, you should remember a reaction with KCN. That reaction will happen somewhere. You have OH, and it is going to give you 1, 2, 3 carbon atoms COOH. Please remember that. This is 2 carbon atom, this is 3 carbon atom. Okay? So first of all, I will convert this to haloalkane using SOCl2, and I will get 1, 2 carbon atoms and a chlorine. Then I will add KCN to this, and I will get 1, 2, 3 carbon atoms of nitrile, and then I will do 2 steps for carboxylic acid. First step will be pani, second step will be H plus in the presence of heat. So this is how you can ascend in the series. That means 2 carbons से 3 carbons आप जा रहे हैं. ठीक है? Alcohol to carboxylic acid. Here also we were having alcohol to carboxylic acid, but here there was no increase in the number of carbon atoms. That is why we just oxidized it. But when we are having increase in the number of carbon atoms, then we have to use a pathway. ठीक है? Make sense? Yes or no? Krishna Priya and Yusuf? हाँ जी बताएं.
Yes.
ठीक है, very good. After this, you will write fourth one. I think this is fourth now. 3 हो गया. Yeah. From Grignard reagent. from Grignard reagent. Grignard reagent is R mgx plus you need CO2, carbon dioxide, that is O double bond carbon double bond O, right? Now what will happen here? Please see. Alkyl group, it is attached with a metal atom. Metal has a tendency to lose electrons. So this metal atom, it is giving electron density towards the carbon atom, making the alkyl group electronegative. That means it is delta negative. I mean, it is having a high electron density here. So the alkyl group can easily attack on the carbon atom because carbon is attached with two oxygen atoms via double bond. Both the oxygen atoms are more electronegative, making this carbon atom delta positive. Make sense? Yes or no? Now you will have R that is bonded with carbon atom, which has a double bond O and one O negative, which is having a ionic bond with MgX because MgX has broken a bond. It has got a positive charge. Oxygen has a negative charge. After this, you just need to add Pani and you will get R, C double bond O and OH. Here also, if you see the initial alkyl halide that we had, the Grignard reagent, it was having R number of carbons. Here we are having R plus one number of carbon atoms. So there is an increase in number of carbon atoms by one. So in this reaction, what happens? We will write when Grignard reagent is treated with carbon dioxide and further hydrolyzed with H2O, it forms carboxylic acid with one carbon more than the Grignard reagent than the Grignard reagent. That means जो हम लोगों ने एक कन्वर्जन किया था इथेनोइक, अच्छा चलिए कुछ हम लोग सिंपल एग्जांपल्स पहले ले लेते हैं. फॉर एग्जांपल, इफ यू हैव समथिंग लाइक दिस, your benzene ring which is having a Br group attached here, and here you are doing a sequence of reactions. In the first step you are adding Mg, so you will get Grignard reagent. Second step you are adding carbon dioxide, so you will get the addition product. Third step you are adding Pani. ठीक है? So what will happen? You will just get बेंजीन रिंग, इसमें एक कार्बन जोड़ दीजिए आप, जहां पे Br लगा ना वहां पे COH. ठीक है, दैट्स इट. फॉर एग्जांपल, इफ यू हैव समथिंग लाइक दिस, let's suppose you have now chlorine. We are using the same reagents, all the three. Then wherever chlorine is attached, you will add carboxylic acid, COH. ठीक है, that's it. Now the conversion that we did was ethanol to propanoic acid. Ethanol to propanoic acid. So we can use this particular reaction. First of all, we have two carbon atoms and OH. Propanoic acid will be having three carbon atoms and COH in the third carbon atom. So I will first of all convert this to alkyl halide, that is using SOCl2. So I will get Cl here. Then I will add here Mg. So when I add Mg, I will get MgCl. And the third step, I will do the three-step reaction. That is, first step is, Mg is done already. So CO2, and the second step is going to be H2O. And I will get in the place of MgCl, I will be getting carboxylic acid. Okay, so this is also, we can use this method in order to go from ethanol to propanoic acid. Here also there is an increase in carbon atom by 1. Okay, so this type of reaction can be used in other cases also. ठीक है, तो इसका थोड़ा ध्यान रखिएगा. Copy this down, raise your hand once you're done. You understand? Just give me a second to set up your test. Write the fifth method of preparation. From acyl halide. It's a very easy reaction. Acyl halide, you just need to add water. If you have any acyl halide, RC double bond O, Cl, add water to it, you will get R, C double bond O, Cl will be replaced by OH, और साथ में आपको क्या मिल जाएगा, H2O मिल जाएगा, ठीक है. But this reaction is in fact quite slow. ठीक है. आपको OH लगाना है तो अच्छा होगा कि आप क्या करें, बेसिक कंडीशन लेके आए. So if you have R, C double bond O, Cl, and if you have a basic condition like this, OH negative, then you will get what? R, C double bond O, O negative, and then you will add H plus, the presence of water. फिर आपको क्या मिल जाएगा यहाँ पे? You will get R and OH. Okay. So this is a bit faster. Sixth method of preparation is from esters. From esters. The esters, they have a molecular formula like this: R, C double bond O, that is bonded with oxygen, and then further bonded with some alkyl group R dash. When you are going to add water in the presence of acid H plus and water, then you will get R, C double bond O. This oxygen atom will get OH, and one of the OH from H2O is going to attach on R dash. So you will get R dash OH, alcohol plus carboxylic acid. Okay. So for example, if you have something like this, double bond O, and you have OCH3, H plus in the presence of water, get benzoic acid. The C double bond will be in its place. You'll get OH here, plus you will get CH3OH. That's it. If you have something like this, oxygen, then carbonyl carbon, and then CH3, then CH3CO will be constant, CH3, C double bond O, and OH will be as it is, plus you will get phenol. Right, next, seventh method of preparation. From acid anhydrides. ठीक है. Acid anhydrides, what are these? You have R, C double bond O, O, carbon, C double bond O, and then you have some R dash. You just need to add water into this, and you will get R, COOH, plus you will get R dash COOH. होता कैसे ये रिएक्शन? काफी आसान है. यहाँ पे आपके पास आप पानी डाल रहे हैं, hydrogen and OH will be there. So oxygen atom will attack onto the hydrogen. The oxygen lone pair from the water molecule will attack on the carbonyl carbon. Okay, this bond will break. So you have R, C double bond O, OH, R dash C double bond O, and OH. You get two molecules of carboxylic acid. Now, depending on the type of anhydride we have, let us suppose we have something like this: oxygen and three carbon atoms here. Here we have a double bond O. Here also we have double bond O. So here you have two carbon atoms. Here you have three carbon atoms. When you add water, you will get a carboxylic acid with two carbon atoms and OH. Plus you will get a carboxylic acid with three carbon atoms and COOH. That's it. Write the last MOP, that is from ketones and aldehydes. From ketones and aldehydes with CH3 C double bond O fragment. ठीक है. This is basically the haloform reaction. If you have R, C double bond O, and you have here CH3, then what will happen in the presence of NaOH plus any halogen, or you can also write NaOX, sodium hypohalite. You will get R, C double bond O, and ONA, plus you will get CHX3, that is haloform. है ना? In case of iodine, you will get iodoform, क्योंकि एक test होता है. You don't have to worry about this haloform. When you further react this with H plus, in the case of you are going to bring acidic condition, आपको यहाँ पे मिलेगा R, C double bond O, and you will get OH. ठीक है? That is carboxylic acid. Now, important point here is the product form. The product, or rather, the product formed will be a carboxylic acid with one carbon less. ठीक है? तो यहाँ पे आपके पास कई सारे एग्जांपल्स आ सकते हैं. See here, for example, if you have aldehyde के केस में you have only one example, that is CH3 C double bond O, and you can have only hydrogen, है ना? Then only this reaction will occur. In the first step, you have I2 and NaOH, and the second step you have H plus. So what would happen here? You have how many carbon atoms? 2 carbon atom का aldehyde है, तो आपको एक carbon atom का क्या मिल जाएगा? Carboxylic acid मिल जाएगा. ठीक है? Plus you will be getting CH3, that is another thing. ठीक है? But you are getting one carbon atom less. Next you have 3 carbon atoms and a ketonic group like this. First step में you have Br2 in the presence of NaOH. Second step में you have H plus atom. So what will happen? 3 carbon atoms, तो 2 carbon atom कर दीजिए इसका. CH3COOH plus CHBr3 हो जाएगा अब, है ना? That is bromoform. Okay. If you have 4 carbon atoms like this, double bond O, same reagents, then what we are going to get? 4 carbon atom का 3 carbon atom कर दीजिए, COOH कर दीजिए, plus you will have CH, what Br कर दो तो Br3. ठीक है? So this is all the method of preparation of carboxylic acid. There are 8 methods. 8 method of preparation of carboxylic acid. Please revise it today itself, है ना? आज ही के आज क्या कीजिए, एक नोटबुक बनाइए, उसमें 8 रिएक्टेंट्स लिखिए और उसके प्रोडक्ट्स लिख दीजिए. ठीक है? अगर आज नहीं करेंगे तो फिर दिक्कत हो जाएगी. If you are done, we will move towards the physical properties. See here, guys. Right, next, physical. Okay. Now, in physical properties, you write the first point that carboxylic acid have higher boiling point than comparable aldehyde, ketones, and even alcohol. Right, this is due to extensive hydrogen bond between carboxylic acid, which enables them to form dimer. What happens in carboxylic acid is you have R, C double bond O, and OH here. Okay. And you have, let us suppose, carbon atom, double bond O, and OH here. And here you have R. So these are the two molecules of the same carboxylic acid. When you have carboxylic acid on any of the molecules, that molecule will not be individual. It will be having billions of its companions, right? So what would happen? There will be a interaction between the hydrogen and oxygen. So you have an interaction here like this and here like this. Since two of the molecules are interacting so closely, what will happen? This will and separating these two. Now you have to break two hydrogen bonds, and there is also a formation of ring here. So it becomes a quite difficult task in order to break this particular dimer. Okay, that is why carboxylic acid, they have boiling point higher than the alcohols also. Alcohol में वहां पे सिर्फ और सिर्फ एक ऑक्सीजन एटम होता है, that is responsible for the hydrogen bonding. Here we have two oxygen atoms. ठीक है, and that is why hydrogen bonding is stronger here, and it is so strong that it forms a dimer. Now, right next, the second point is carboxylic acid can form dimer in vapor phase and aprotic solvent. Okay, so it can also form dimer in vapor phase. That means when it is in vapor, and aprotic form, that means when it is in the solvents such as benzene, carbon tetrachloride. These are aprotic solvents. So if it is there in aprotic solvent, aprotic means the solvents which do not have OH type of bonding. ठीक है, जैसे इथेनॉल हो गया, वाटर हो गया, ऐसे में नहीं. बट इफ इट इज इन एप्रोटिक सॉल्वेंट, बेंजीन वगैरह में है, तो फिर आराम से क्या करता है, फॉर्म से डाइमर. You will write next. Carboxylic acid can form hydrogen bond with water. Therefore, it is soluble in water. ठीक है, it is soluble in water. Right, next point. As the number of alkyl group, as the number of carbon atom in alkyl group, carbon atom in alkyl group of carboxylic increases, the solubility decreases. Right, next. Carboxylic acid are also soluble in organic solvents. Please raise your hand once you are done. Okay, both of you are done.
Yes, sir.
Right, next, chemical properties. No. Number one, acidic character. ठीक है. Now, for acidic character, we will first of all talk about the reaction that it is giving. है ना, the reaction it is giving in order to show the acidic nature, and then you will talk about the acidic strength also. ठीक है, तो acidic character में you will write the A part, reaction with metals and alkalis, metals and alkalis. ठीक है, so for example if you have RCOOH plus sodium, it is going to react because acids they react with metals and it gives you what, H2 gas. Okay, so you will have RCOONA plus separated. Okay. Now carboxylic acid, that is RCOOH, it can also react with sodium hydroxide NaOH, and it is going to give you RCOONA sodium carboxylate plus water, acid and base reaction. It can also react with carbonates. Okay, so you have RH plus Na2CO3, that is a carbonate. You will get RCOO Na plus CO2 plus H2O. Now CO2 is a gas, and we can use this as a test for carboxylic acid. Similarly, you can have RCOOH plus sodium bicarbonate or sodium hydrogen carbonate. You will get RCOONA plus CO2 plus H2O. Okay? So both of these things can be used as test for carboxylic acid. Used as test for carboxylic acid. ठीक है, राइट, मतलब क्या टेस्ट होता है, or rather I should write carboxylic acids with NaHCO3 or Na2CO3 to form CO2 with brisk effervescence. Which turns lime water milky. Which turns lime water milky. ठीक है, next B part is the acidic strength. ठीक है, B part is the acidic strength. In acidic strength, we have carboxylic acid, that is R, C double bond O, OH. If it shows acidic strength, then it will give you RC double bond O, O negative plus H positive. Now, this is known as carboxylate ion. ठीक है, and we can write the Ka for this. It will be what? The concentration of the carboxylate ion, COO negative, into H positive divided by the concentration of the carboxylic acid, है ना? COOH. Now, if there is a strong acid, or if you are having more H plus ion, then what will we say? We will say it is a stronger acid. सही है? So हम यहाँ पे कुछ बातें लिख सकते हैं. Please see. If you have more H plus, meaning it is a strong acid. If you have more H plus, then the numerator is high. That means Ka will be more. So if you have high Ka, it would mean that is a strong acid. Okay. Now, we know that pKa is defined as minus log of Ka. So if the concentration of H plus is high, that means the Ka is high. If Ka is high, that means the log of Ka will be high. But if the log of Ka will be high and you minus log Ka, this thing will be low. And what is minus log Ka? It is nothing, but it is actually what? It is the pKa. So pKa is strong if you have more H plus. And if you have more H plus, it is a strong acid. That means we can say strong acids have lower pKa. Make sense, yes or no? Krishna Priya and Yusuf?
Yes, sir.
Okay.
Yes, sir.
Both of you are done? Okay. So let us do a question. Just give me a second. You have been given the pKa value. You have, this is molecule A, this is molecule B, and this is molecule C. Okay. So you have to arrange them in the increasing order of acidic strength. Send your answer in the chat. You have been given the pKa values, है ना? तो pKa values को देख के जरा बताइए. You will send the answers in the Zoom chat. No, you have to arrange A, B, C में आपको arrange करना है. Okay, Krishna Priya. Right. Both of you are given same answer, so hopefully it is right. See. So what they have given you the pKa value, right? pKa को पहले arrange कर लेते हैं. So we have the smallest pKa for the C structure. C is having the smallest pKa, which is followed by carboxylic acid, that is B structure, and then we have pKa, that is A. Okay, so this is pKa. What about the acidic strength? Acidic strength will be reversed, na? है ना? A, then B, and then C. ठीक है. I hope you guys have answered correctly, ना? A का सबसे ज़्यादा पता आप लोगों ने. Oh, Krishna Priya, you have done the opposite. Krishna Priya?
Yes, sir.
C. नहीं, हमने उल्टा लिख दिया है क्या? Oh, sorry, my bad. A is most acidic, then B, then C. ठीक तो लिखा हमने ठीक लिखा. आपने उल्टा लिख दिया है. आपने बोला C is most acidic.
Oh, I put the sign wrong, sir.
एक सेकंड. Wait. No, my bad. हमने दोनों को ठीक आपका ठीक है. C, B, A with the opposite signs. Sorry, my bad. This is fine. यूसुफ का उल्टा था, right, यूसुफ?
Yes, sir.
है ना? My bad. pK is inversely proportional to acidic strength. My bad. Krishna Priya, yours was correct. ठीक है. So this is the acidic strength. Now, ये तो अगर आपको pK दिया रहे तब आप ऐसे निकाल सकते हैं. Now we are going to compare a few things. ठीक है. So first of all, we are going to compare the acidic strength of carboxylic acid versus phenol. ठीक है, versus phenol. Now, for this, we have to compare the conjugate base of carboxylic acid and that of phenol. So if you look at phenol, OH, which will give you phenoxide ion plus H positive. ठीक है. Now, if I show the resonance, then this is having resonance like this. Let's want to move here. When I talk about carboxylic acid, then carboxylic acid is RCOOH, and it is going to break apart into R, C double bond O, O negative plus H positive. ठीक है. Now, in this case, the resonance is like this. This O negative, it goes here. This bond and this pi bond breaks and it goes to this oxygen atom. ठीक. Now, there are 2 points. पहले तो सबसे पहले बिल्कुल आप क्लियर रखिएगा. Carboxylic acid and versus phenol, which is more acidic. जिसके नाम में acid है, carboxylic acid, that is more acidic. ठीक है. First thing, you will be very clear. Carboxylic acid is more acidic. Why? Because उसके नाम में ही क्या है? You have acid there. So carboxylic acids are more acidic than phenols in general. If you have substituted phenol में कुछ चीज लग जाएगी, then it is different case. But in general, carboxylic acids are more acidic than phenol. What is the reason? The reason is the conjugate base of phenol, that is the phenoxide ion. And the conjugate base of carboxylic acid, that is the carboxylate ion. Carboxylate ion. So the reason is carboxylate ion is more stable than phenoxide ion. That is why carboxylic acid is more acidic than phenol. So first point, carboxylic acid is more acidic than phenol. ये एक सवाल आ सकता है आपका. Which is more acidic? Why carboxylic acid is more acidic than phenol? Because ion, I will write like this, RCOO negative is more stable than RO negative. Sorry, not RO, I should write PHO negative. Phenoxide ion. Carboxylate ion is more stable than phenoxide ion. ठीक है. अब यहाँ पे देखिए एक चीज आपके पास एक और सवाल जो आ सकता है. That will be one more level of Y. One more level of Y would carboxylate ion is more stable than phenoxide ion, even though phenoxide ion has more resonating structures. Phenoxide ion, this negative charge will move here, then it will move here, then it will move here. So it will make around 5 resonating structures. In carboxylate ion, we have only 2 resonating structures, but still carboxylate ion is more stable. Why is that? So the reason is, please see, हम बेंजीन का ना, सॉरी, फेनॉक्साइड आयन का आपको रेजोनेंस हाइब्रिड बना के दिखा रहे हैं। O, this carbon atom will have delta negative, this carbon atom will have delta negative, and this carbon atom will have delta negative, है ना, यहाँ पे चार्जेस आएंगे. In terms of carboxylate ion, you have R, that is having carbon, it is attached with carbon, and it will be like this. So here you will have delta negative charge on this oxygen, delta negative charge on this oxygen atom. Now tell me, which will be easily bearing a negative charge? Oxygen atom or carbon atom? किसके कौन आसानी से नेगेटिव चार्ज बियर कर सकता है? Tell me guys, what do you guys think? Oxygen or carbon, which has the ability to bear negative charge more, which can easily bear the negative charge? अरे बोलो भाई, कृष्ण प्रिया and Yusuf, what do you guys think? Think na, who is more hungry for electron, carbon or oxygen? Who is more hungry for electron, carbon or oxygen? Oh my god, Krishna Priya and Yusuf, you can't even answer this.
Oxygen.
Oxygen is more hungry, no? Oxygen is more electronegative. If it is more hungry, oxygen always says, give me electron. That is why negative charge on oxygen atom is more stable. In the case of phenoxide ion, we are having negative charges on carbon atom. In the case of carboxylate, we are having the negative charge on oxygen atom, which is more electronegative. That is why it is more stable. Another thing. In the phenoxide ion, the negative charge is distributed among oxygen also, because oxygen ke paas se RF सबसे पहले, so here also have delta negative, I forgot that, delta negative oxygen, as well as carbon. All the resonating structures in the phenoxide ion is different. They are nobody is same. I mean, all the resonating structures are different. And in all the resonating structures, the electron is going in a different atom. But in the case of carboxylate ion, we have what we call equivalent resonance. And whenever we have equivalent resonance in which the negative charge or the positive charge is going to the same atom, then we say equivalent resonance, and that is way more stable. Because both the structures that we are having for carboxylate ion, they are completely same. या तो उस ऑक्सीजन पे नेगेटिव या तो उस ऑक्सीजन पे नेगेटिव, राइट? तो दीस टाइप ऑफ स्ट्रक्चर्स आर नोन एज इक्विवेलेंट स्ट्रक्चर, एंड दैट इज व्हाई दे आर स्टेबल. जो आपके पास अगला, why is carboxylic acid more acidic than phenol, even though phenoxide ion has more resonating structure than carboxylate ion? Then you will write this third point. That is going to be a bit long. ठीक है, क्या लिखेगा? You will write RCOO negative is more stable than PHO negative, that is phenoxide ion. PHO negative because number one, RCOO negative carboxylate ion has, or rather shows, equivalent resonance. Second point, in RCOO negative, the negative charge is always on more electronegative oxygen atom, whereas in phenoxide ion, the negative charge is on less electronegative carbon atom. ठीक है? So there are three questions that can be asked from this topic itself. और तीनों के आंसर ही अलग है. First is they will ask you compare. They can ask you to compare between carboxylic acid and phenol. ठीक है? So carboxylic acid is more acidic. That's it. Done. Why is carboxylic acid more acidic than phenol? Because carboxylate ion is more stable than phenoxide ion. Done. खत्म. Why is carboxylate ion more stable than phenoxide ion, even though phenoxide has more resonating structure than these 2 points? Make sense, Krishna Priya and Yusuf? Yes or no? आप कंफ्यूज मत होइएगा प्लीज. ठीक है, आप लोग अब देखिए इस सवाल आए हुए हैं. इफ यू सी द क्वेश्चंस ऑफ एनसीईआरटी, इफ यू रीड एनसीईआरटी, देन यू विल फाइंड दिस टाइप ऑफ क्वेश्चंस, है ना? तो जो सवाल है उसका जवाब लिखना है आपको, है ना? चलिए, रेज योर हैंड इफ यू आर डन. डन, ओके। अब आपके पास है, ये तो एसिडिक स्ट्रेंथ हो गया कार्बोक्सिलिक एसिड का, ठीक है। नेक्स्ट द सी पार्ट दैट वी आर गोइंग टू सी इज द इफेक्ट ऑफ सब्स्टिट्यूएंट। ना ये तो प्योर प्लेन कार्बोक्सिलिक एसिड था ना, वेनिला, नथिंग वी हैव एडेड हियर, ठीक है। आपके पास सी है, टॉपिक इफेक्ट ऑफ सब्स्टिट्यूएंट। इफेक्ट ऑफ सब्स्टिट्यूएंट, ठीक है। In effect of substituent, as we have seen, that we have RCOOH, it gives RCOO negative plus H positive. Now, whatever instability that the carboxylate ion will have will be only because of this negative charge. If we lower the negative charge, then the carboxylate ion will be more stable. ठीक है? So since acidic strength of carboxylic acid depends on stability of the RCOO negative, then in that case, if I have an electron withdrawing group attached to carboxylic acid or carboxylate ion, let's suppose we have an electron withdrawing group. This is attached with है ना, CO negative, it is having bearing the charge ना, resonance show करके हमने यहाँ पे दिखाया है. So there are two cases you can have. You can either have a electron withdrawing group or you can have a electron donating group. ठीक है, दोनों केसेस को देख लेते हैं, देखिए जरा. So if you have a electron withdrawing group, and it will pull the electron density, then what will happen? The charge will be lowered. When the charge is lowered, then stability increases. And then what happens? The acidic strength increases. Acidic strength increases, and what happens to the pKa? pKa decreases. But if you have electron donating group, then this will give electron density towards the negative charge. And what will happen? The charge would increase, stability would decrease, acidic strength would decrease. Stability decrease, acidic strength will decrease, and the pKa would increase. Copy this down. Raise your hand once you're done. अच्छा, इसके बाद ना एक चीज साथ साथ लिख लीजिए जरा, द ऑर्डर ऑफ इलेक्ट्रॉन विड्रॉइंग ग्रुप, है ना, प्लीज राइट दिस विथ मी. ऑर्डर ऑफ इलेक्ट्रॉन विड्रॉइंग ग्रुप, है ना. सो विच इलेक्ट्रॉन विड्रॉइंग ग्रुप इज गोइंग टू पुल द मोस्ट इलेक्ट्रॉन डेंसिटी. ठीक है, चलिए. अच्छा, पहले इसको लिख लीजिए जरा. राइट दिस होल थिंग डाउन, आई विल राइट दी, whether I can, yeah, I think this would work. So the least is done by any benzene ring, followed by any iodine group, bromine, chlorine, fluorine. ठीक है, if you have one. Then it is followed by cyanide, if cyanide is attached. It is followed by NO2, and less. Then the last one is if it is attached with CF3, three fluorine atoms attached to a carbon atom, which is further attached to carboxylic acid. Then it has the maximum electron withdrawing capacity. Copy this down. Yusuf, raise your hand once you're done. Yusuf, just waiting for you now. ठीक. Which of the acid pairs shown here would you expect to be stronger? ठीक है, So number 1, ठीक है, number 1 we have CH3CO2H. That means we have CH3COOH versus we have what? We have CH2 which is attached with fluorine. CH2, it is attached with fluorine, attached with carboxylic acid. So here if I compare which is having electron withdrawing, what fluorine is what? It is electron withdrawing group. That means this will be more stable. Sorry, that means this is going to be more acidic. If I compare these two, this is more acidic, right? Because it is having an electron withdrawing group. Second, what level wise यहाँ पे this is one of the most appropriate way of giving questions in the NCERT है ना, इतना अच्छा काम उन्होंने और कहीं नहीं किया. Second देखिए कैसे level ऊपर जा रहा है. You have CH2, this is attached with a fluorine, and then you have carboxylic acid, versus you have CH2 that is attached with carboxylic acid group, and then you have here chlorine attached. Hai? Now see, both of these are having electron withdrawing group, fluorine as well as fluorine. दोनों ही क्या है? दोनों ही these are electron withdrawing group. But which is more electron withdrawing group? The fluorine atom. Fluorine is having higher capacity to withdraw electron, as we have seen in the order of electron withdrawing. सही है? That is why this is going to be more acidic, the fluorine one. Now in the next case, देखिए थोड़ा सा level आगे बढ़ा है. Here you have how many carbon atoms? Here you have, let us suppose, take 1, 2, 3, and 4. So you have 4 carbon atoms like this. Fourth carbon atom is having COOH, and you have fluorine in which carbon atom? The first carbon atom. ठीक है ना? CH2 fluorine. So fluorine is here. Now versus we have something different. That is again 4 carbon atoms. COOH, and fluorine is in the first carbon, second carbon, third carbon atom. Fluorine is here. COH, CH2, and then you have CH, so you'll have fluorine here. Okay? Now, here they are talking about the distance dependence of the fluorine group. Now, fluorine is nearer to the carboxylic acid group in the B case, जो दूसरा वाला है. That is why it will be able to pull the electron density much easily from the carboxylic acid if it is near to the carboxylic acid. That is why this is more acidic. And the last case is again simpler case, fourth wala. We have CF3, which is bonded with benzene ring, having a carboxylic acid group, versus we have CH3 bonded to benzene ring and then carboxylic acid group. Obviously here the CF3 is what? Is electron withdrawing group. That is why it will be having more acidic strength. So the first question, it was completely based on what? Presence of electron withdrawing group. The second question, fluorine versus fluorine, it was the power of electron withdrawing group. The third question of fluorine and fluorine, both of them are what? Same electron, same power. But here we are talking about the distance dependence. Distance dependence. If fluorine is near, dependence. If fluorine is near, then it would be having what? It would be easily pulling the electron carboxylic acid. Make sense? Yes or no, Krishna Priya, Yusuf? Asan Magi? Anji बताएं.
Yes, sir.
What about you, Yusuf? Is Yusuf not here? Shall you raise your hand once you're done? That's समझ में आ गया. Okay, Yusuf. Moving on. Let us see next. That is the acidic strength when you have benzoic acid. Okay, where you can have the mesomeric effect kind of thing. So if you talk about the acidic strength, it is directly proportional to the minus M group, because minus M group, they have the capacity to pull the electron density. These are electron withdrawing, and they are inversely proportional to the plus M groups. ठीक है. So we have a question here. No, 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 no. Where is the question, bhai? हाँ. You have to arrange the following in increasing order of acidic strength, and these are the options. ठीक है. You have A, benzoic acid. Write it in some different color. You have A, that is benzoic acid, B, 4-nitrobenzoic acid, and C, 3,4-nitrobenzoic acid, and 4 is methoxybenzoic acid. है ना. इसमें बस हमने एक चीज आप लोग के ऐड कर देते हैं, that is plus M or minus M effect is only observed at ortho and para positions. ठीक है. चलिए प्लीज टाइप दिस डाउन. Okay, Krishna Priya, let me see. B, A, B, C. चलिए ठीक है. Let us see. So we have benzoic acid first of all. Benzoic acid is going to be simple benzene ring with COOH, nothing attached. Then we have 4-nitrobenzoic acid. That means we have benzoic acid like this, attached with NO2 group in the para position. 4, 3,4. That means we have benzoic acid. Third position is having NO2, and this position is also having NO2. Then we have the methoxybenzoic acid. That means we have carboxylic acid group in this position, and you have OCH3 here. And this is A, this is B, this is C, and this is D. Now, the highest acidic, first of all, let us see. There is no group here, so that means will be no effect. NO2 group, it will be having minus M effect because it is in the para position. Here also it is in the para position, that means it is going to have minus M. Here it is in the meta position, that means it will have minus I. Here OCH3 is present, which is having lone pair electron ski atom, that is why it is going to have plus M effect. Now, if we are going to compare the acidic strength, then obviously the minus one will be having the highest acidic strength. So सबसे ज़्यादा होगा C के पास, followed by B, and then will come the 0, that is A, and then you will have D. So C is the most, followed by B, followed by A, and followed by D. Yeah, that is correct. Very good. Very good, Krishna Priya. So if you want to draw these structures, you can draw these structures, and then we will look at next topic, next reaction rather. Right, next, reduction of carboxylic acid. Okay. So in reduction of carboxylic acid, we can use two different reagents. We have RCOOH, and both of these reagents are going to give you the same product. Okay. First one is lithium aluminium hydride. Second step में आप पानी डाल दीजिएगा. Then you have diborane B2H6. Second step में पानी. In the presence of acid, you will get both the cases are CH2OH. That means it forms alcohol with the same number of carbon atoms. Forms alcohol with same number of carbon atoms. This is one of the simple reactions. इसमें जनरली बच्चे ना एक में थोड़ा मिस्टेक कर देते हैं, that is benzoic acid. If you use any reducing agent such as lithium aluminium hydride, बच्चों को लगता है कि phenol बन जाएगा, but you will not get phenol, rather you will get benzyl alcohol. The carbon atom will be as it is, और इसमें OH लग जाएगा. ठीक है, चलिए third reaction please write. Helmholtz-Zielinski. Helmholtz-Zielinski, that is HVZ. Now what happens in this reaction, we will first of all look at that, and then we will write what is happening. We have RCH2 COOH. Okay? In the presence of halogen and red phosphorus, which is then further hydrolyzed with water, you get a halogen atom on the alpha carbon. So you have R, CH as it is, and you will get what? You will get here halogen X, and COOH is as it is. उसको कुछ नहीं होता है. ठीक है? For example, if you have COOH, you have here Cl2, red phosphorus, second is H2O. So 1, 2, 3, 4 carbon atoms, carboxylic acid COOH, and here you will get chlorine. ठीक है? Now, if you do the same thing, यहाँ पे देखिए दो hydrogen atoms, one more hydrogen is left, right? So if you do the same thing as previously, you will get one more chlorine atom there. ठीक है? One more chlorine atom. So you will get two chlorine atoms here if you react once again. ठीक? For example, if you have, let us suppose CH3 COOH, and you are reacting this with Cl2 in the presence of red phosphorus, और second step में आप क्या डाल रहे हैं? पानी. Then what would happen if you do this reaction 3 times? ठीक है? 1, 2, and 3. ठीक है? So all the three hydrogen atoms will be replaced with chlorine. और आपको क्या मिलेगा? You will get Cl3 carbon, which is further attached with COOH. Make sense, Krishna Priya? Yes or no? Please tell me.
Yes, sir.
ठीक है? Now, another case is when you have something cyclic which is attached with carboxylic acid. COOH. Same thing. Then what will happen? The COOH will be as it is. This is the alpha carbon. It has one hydrogen. It will react with the reagent and it will give you, let us suppose, chlorine. तो यहाँ पे chlorine मिल जाए. You write carboxylic acid having at least one alpha hydrogen . reacts with halogen and red phosphorus. Then further hydrolyzed with H2O. Leads to replacement of hydrogen with halogen on alpha carbon. Then Krishna Priya,
Yes, sir.
right, next reaction. Formation of anhydride. Now, when you have carboxylic acid, that is R, C double bond O, and OH, and you have some other carboxylic acid or the same carboxylic acid, I'm writing it in this order, HO, which is having C double bond O and R dash. Okay. So what would happen? The hydrogen from one of the carboxylic acid and the OH from the other carboxylic acid, they will combine to form water. This reaction happens in the presence of H plus and heat. The reagent that we use is P2O5. Achha, both of these we can use any one of these, P2O H plus and heat or P2O5 or heat. Okay? And what will happen? You will have R, C double bond O, bonded with oxygen, C double bond O and R dash. This is the formation of anhydride. Okay? So if you have, let us suppose, acetic acid, CS3, COOH plus, or rather, if you have only acetic acid, na, tab dekh lete. So if you have in the presence of H plus and heat, what would happen? You will get acetic anhydride. Usme kya hoga? CS3, carbon double bond O, oxygen, carbon double bond O, and then CS3. This will be known as acetic acid. Oh, my bad. Acetic anhydride. Yeah, acetic acid. Acetic anhydride. This is acetic acid. See next, fifth reaction. Now all of these reactions are quite similar. Okay, now fifth reaction mein formation of ester. In formation of ester, you have R, C double bond O, OH plus any H. In the presence of acid, it forms R, C double bond O, and OR dash. That's it, ester. ठीक है, यहाँ से भी आप देख सकते हैं what is happening here. You can see that here and OH from here. पानी निकल रहा है यहाँ से भी, same thing, right? Water is removed from here. So, am I audible properly, Krishna Priya?
Yes, sir.
Plus, you have, let us suppose, 2 carbon atoms and OH in the presence of H plus. ठीक है, the presence of H plus. So you have 3 carbon atom carboxylic acid. So 3 carbon atom, and then you will have the carbonyl carbon. Then you will have the oxygen and the number of carbon atoms in the alcohol group. यहाँ पे आपके पास क्या जाएगा, C2H5. ठीक है, so this is the ester that you are going to get. नाम इसका क्या होगा देखिए, ethyl 1 2 3 carbon atom propanoate is known as ethyl propanoate. ठीक है, इस तरह से नेम करते हैं. First of all, you write the alkyl group that is attached on the oxygen atom. Then you write the number of carbon atom that is attached with the carbonyl carbon. 1 2 3 propane. If you have any double bond here or there, then you write En or something like that. And O8 is the functional group name for esters. Now, sixth reaction is quite important because it is used in different types of organic conversions. That is formation of acid chloride. Formation of acid chloride. ठीक है, formation of acid chloride, you have carboxylic acid R, C double bond O, OH. Now you can use 3 different reagents. All of them are going to give you the same product, ठीक है, with different byproducts though, but again the main product is going to be same, PCl5, or if you have PCl3, or if you have SOCl2. In all of the cases, OH will be replaced by Cl. You will have R, COCl. In the case of PCl5, you have POCl3 plus you have Cl2. In the case of PCl3, you will have R, COCl, that is acid halide, plus you will have H3PO3. In the case of SOCl2, you will have R, COCl as it is, plus you will have SO2 plus HCl. ठीक है, so all of these reactions can be used. अब देखिए COCl अगर आपके पास आ गया ना, that is acyl chloride. From here you can go to aldehyde also, है ना? So you should remember this reaction. Now next is the formation of amide. Seventh, formation of amide. In formation of amide, we react carboxylic acid R, C double bond O and OH with ammonia, that is NH3. When you will react with NH3, the lone pair of nitrogen atom will attack on the acidic hydrogen of carboxylic acid, and you will get a salt that will look something like this. You will have R, that is O negative. The nitrogen atom gets 1 hydrogen and it becomes NH4 positive. ठीक है, now this is the salt. When you are going to heat it, water is removed from this salt. ठीक है, water is removed from the salt, minus H2O, and you are remaining with R, C double bond O as it is. ठीक है, तो एक ऑक्सीजन निकल गया यहाँ कार्बोनिल कार्बन से और 2 हाइड्रोजन निकल गए यहाँ से, so you are remaining with NH2. ठीक है, that is amide. Amide is also an important formation because it is used as a synthesis material, as a starting material for different reagents. The formation of amide में ही एक आपके पास specific reaction है that is important. ठीक है, so for example, if you have something like this, RCOOH in the presence of ammonia, and then heat, you will get RCONH2. This reaction is also possible if you have any that contains benzene ring. So you have COOH, same reagent, you will get CONH2. ठीक है, अब यह reaction, that is preparation of halimide. Now halimide is used as a synthesis material, synthetic material for just give me a second. Preparation of phthalimide. In preparation of phthalimide, we take phthalic acid, COOH, here also COOH. ठीक है? In the presence of ammonia, what will happen? Both of these will be converted to the salt COO negative, NH4 positive. COO negative, NH4 positive. After that, when you heat it, you will get COONH2. That is CONH2. CONH2. Okay. Here also you will get CONH2. Next is, if you heat it once again, you got water removed from here. When you will heat from here, you will be removing NH3. 1 nitrogen and 3 hydrogens will be removed. So the benzene ring will remain as it is. And you will be having C double bond O as it is. Here also C double bond O as it is. 1 nitrogen with 1 hydrogen. NH. Okay? 4 hydrogens were there, 3 hydrogen is removed, 1 hydrogen is left. 2 nitrogens were there, 1 nitrogen is removed, 1 nitrogen is remaining. Okay? So this is known as phthalimide. This is PHLIMIDE, phthalimide. Okay? Phthalimide is also a very important synthetic material in the medical industry. Then Krishna Priya?
Yes, sir.
No, right. The last reaction, that is decarboxylation. There are two methods for decarboxylation. Ek to soda lime, and then we have coal-based electrolysis. So the basic reaction for soda lime is, first of all, you take the carboxylic acid, you react this with NaOH to get a salt. That is RCOONA, sodium carboxylate. Then you add soda lime. Soda lime is actually a mixture of NaOH and calcium oxide. With a bit of heat, you will get alkane with 1 carbon less. Plus you will get Na2CO3, sodium carbonate. Okay. So it forms an alkene which is having 1 carbon less than carboxylic acid. What does it do? It forms alkene with 1 carbon less than carboxylic acid. ठीक है. Next is coal-based electrolysis. अच्छा, यहाँ पे भी decarboxylation हम लोग इस वजह से बोलते हैं because this COO ना it has been gone as Na2CO3. ठीक है. And if it is present in water, then वो वहाँ पे NaOH plus carbon dioxide वगैरह बन जाता है. ठीक है. That is why this COO is gone ना CO2. So that is why we call it decarboxylation. In coal-based electrolysis, this is also an example of decarboxylation, but it has a different product. Coal-based electrolysis. In coal-based electrolysis, if you use RCOONA, the first step is same, react it with sodium hydroxide, and if you electrolyze it, then you will get R-R. This alkene is what having double the number of carbon, but you have to remove 1 from here, है ना? तो पहले 1 कार्बन निकलेगा, उसके बाद उसको डबल कर दीजिएगा. ठीक है. So if you have n carbon atoms here, ठीक है, then it will be having 2 into n minus 1. ठीक है. n minus 1 into 2. Plus you will have NaOH and you will have carbon dioxide which will be gone. Now the alkene, it is formed at anode because at electrolysis में anode और cathode होगा. NOH is formed at cathode. Carboxylic acid, carboxylate ion, it is removed. So if you have 3 carbon atoms, carboxylic acid, in the first step I am using NaOH. Second step I am using electrolysis. Then what will happen? 3 carbon atoms, 3 minus 1 is 2. 2 का double is 4. So you will get an alkene of 4 carbon atoms. ठीक है? So here the alkene form. Will have 2 into n minus 1 carbon atoms. N is equal to number of atom in carboxylic acid. ठीक है, चलो. अब see, all of these reactions are done. There is only one reaction left. उसका मतलब one type of reaction left. You will do it from your NCERT textbook itself. ठीक है, तो ज्यादा कुछ नहीं है. That is the electrophilic aromatic substitution of carboxylic acid. It's like one paragraph only. I'm just pasting it here. If you like further अगर reference करना पड़ा तो, और उसमें कुछ भी caveat और there is no y type of question, सिर्फ एक है. That is this question here. Friedel-Crafts reaction is not shown because the carboxylic acid is deactivating and the catalyst aluminium chloride gets bonded to the carboxylic group. ठीक है, so ये बस एक y type of question आ सकता है. बाकी it is only 2 reactions. That is benzoic acid से react करेगा and it is going to give you nitrobenzoic acid and bromobenzoic acid. ठीक है, चलिए. So you will do this as homework from the textbook. Fine. Okay, Krishna Priya?
Yes, sir.
And tomorrow we will start with amines. Okay. Please na revise kar lijiyega whatever we have done and specifically the acidic strength and the order of electron withdrawing groups. ठीक है, उसको प्लीज एक बार देख लीजिएगा. ठीक है, क्वेश्चंस आज की क्लास में वो ज्यादा इंपॉर्टेंट है. बाकी नेम रिएक्शंस वगैरह तो जनरली